Welcome to This Explainer. Today, we're jumping straight into the single, incredibly elegant mechanism that finally allowed AI to actually understand context. You see, a few years ago in the evolution of artificial intelligence, we hit this weird plateau. The AI knew exactly what words were, it knew their dictionary definitions, and it knew exactly where each word sat within a sentence. But there was still a massive missing piece. Even with all that raw data, the AI was essentially blind to context.
Which brings us to a really fascinating core question. How does an AI actually know what matters? We know it can identify words and their positions, but how does it figure out which words are actually talking to each other? For a long time, it couldn't. It didn't know that the word "it" in one sentence secretly meant the animal, or that a word 10 spots away might actually matter way more than the word sitting right next to it. Closing that specific gap is exactly what the attention mechanism does, and I would argue it's the single most important idea behind modern AI.
So here is our roadmap for today. We'll cover the context blind spot, the highlighter analogy, a high-tech matching game, scene attention in action, and finally, why it changed everything.
Let's kick things off with Section 1, the context blind spot.
Let's rewind a bit to look at what AI just couldn't do before 2017. Older models, mostly things known as RNNs and LSTMs, process sentences strictly word by word, in order. Imagine reading a really long book, but you're in a pitch-black room and you only have a tiny flashlight. You can literally only see one word at a time, and you have to rely entirely on your own memory to track everything that came before it. Now that worked fine for short sentences, but the moment sentences got long, the whole system just fell apart. By the time the model reached word number 30, it had completely forgotten what word number 2 was. All that vital context just got diluted or entirely lost.
Researchers realized they desperately needed a way for the model to look back at any word in a sentence, not just the most recent one, and decide on its own which earlier words actually mattered. And they totally solved this memory dilution problem in 2017 with the release of a now legendary paper called Attention is All You Need. That paper didn't just marginally improve things, it became the literal foundation for massive tools like GPT, Claude, and Gemini.
Moving right along to Section 2, the highlighter analogy. To really wrap our heads around how this works without getting completely bogged down in heavy math, think about what you do when you're studying a dense textbook chapter for an exam. You absolutely do not read every single word with the exact same intensity. Your eyes naturally just sort of glide over filler words like the, and, or of. But the second you hit a key term or a core definition, you slow down, you highlight it, you underline it twice. You are paying attention. Now just imagine a computer system doing that automatically, mathematically for every single word in relation to every other word in a sentence and recalculating those highlights millions of times per second. That is the attention mechanism in a nutshell.
All right, Section 3, high-tech matching game.
So how does a computer actually pull off this highlighting trick using what is essentially just a giant digital filing cabinet? It all breaks down into 4 clean steps where raw words are mathematically transformed into context-aware representations. First, we start with the input embeddings, which is just the words represented as numbers along with their positional information. Then we jump to attention scoring. This is where the real magic happens, which leads directly to the creation of a context vector. And finally, we get our output.
Okay, let's do a quick pacing reset here. Please don't let the database jargon of query, key, and value scare you off. Think of this whole thing as a high-speed dating app for words, where every single term is out there searching for its absolute best match. For every word, the model essentially asks 3 questions. The query is the word asking, hey, what should I be paying attention to? The key is every other word in the sentence raising its hand saying, here is what I represent. And the value is the actual underlying information that word carries. The model rapidly compares the query against every single key in the sentence. Words that actually matter to each other get a really high score. Words that don't get a low one. After scoring, the model blends those values together, heavily weighted by those scores we just talked about. It's creating a brand new, context-aware blend of information for every single word. The end result is what we call a context vector. It's basically a supercharged version of that original word that now deeply, mathematically understands its relationship to every single other word around it. And that is what gets passed along to the output.
Section 4, scene attention in action.
Now, what's really genuinely fascinating is that we can actually make this invisible math completely visible. Let's look at a classic example. The animal didn't cross the street because it was tired. It's a super simple sentence, right? But there is a massive hidden challenge in there for computer. What exactly does the word "it" refer to? The animal or the street? As humans, we know instantly that it means the animal because obviously streets don't get tired. But a computer doesn't just know that. In this sentence, the attention mechanism dynamically assigns a massive score, creating a powerful mathematical link that connects the word "it" straight back to animal. It figured out that animal is the word most relevant to resolving what it means in this exact context.
But check out what happens when we change literally just one single word at the very end of the sentence. The animal didn't cross the street because it was too wide. The attention mechanism mathematically recalculates on the fly because being wide fits a street and not an animal. The connection dynamically snaps away from the animal and links directly to the street. Guys, it is the exact same sentence structure, but a completely different meaning. Attention is what allows the AI model to catch that nuanced shift automatically every single time.
And finally, Section 5, why it changed everything.
That dynamic snapping and shifting we just saw, that is exactly what allowed AI to scale up so incredibly fast over the last few years. First off, attention handles long-range dependencies beautifully. It doesn't just connect words that are right next to each other, it can connect word number 1 to word number 1000 absolutely seamlessly. Second, it enables massive parallel processing. The model is now looking at all the words at the exact same time, rather than one by one like that flashlight analogy. This massively speeds up the training of modern AI. And third, it gives us interpretability. We can actually visualize these attention scores to see exactly what the model was focusing on, giving developers a literal peek under the hood for debugging.
And this is definitely not just theory on a whiteboard. This specific mechanism is the literal engine powering the AI tools we all use every single day. It's what correctly matches pronouns across complex languages in translation tools. It's the whole reason chatbots like Claude and ChatGPT can actually follow your multi-turn conversations without totally losing the plot. It powers everything from document summaries to code generation and even vision transformers that use attention to figure out which pixels in an image actually matter.
Before we completely wrap up this explainer, let's bust a few quick myths that always seem to pop up around this topic. First, attention means the model is scoring statistical relevance. It absolutely does not mean the AI suddenly possesses actual human understanding or consciousness. Second, as we've seen, its real superpower is connecting distant words, not just the ones sitting side by side. And third, just slapping 100 more attention layers onto a model doesn't automatically guarantee better results. It's really all about how the attention mechanism is smartly integrated with the other components.
So if you take nothing else away today, remember this crucial point. Attention is the mechanism that lets AI dynamically decide which words matter most in relation to every other word for every single prediction it makes. It is the definitive breakthrough that turns static, rigid word meanings into flexible, dynamic, context-aware understanding.
Which naturally leaves us with one massive question. What actually happens when you stack billions of these attention layers together with a few other components? Well, you get the ultimate architecture behind all modern AI, the transformer. But exactly how that giant puzzle fits together, that is a story for our next explainer. Thanks so much for joining me and keep exploring.